Lab 1, Constant Velocity, Physics 2211, Section N. The goal of this lab was to record an object in motion at a constant velocity and direction in an effort to expound upon Newton's second law in our everyday lives. This means we explored an object moving at the same speed in a single direction. Programs such as Tracker and VIDLE were used to extract data positions from a recording, all to explore the fundamental principle in Newton's second law of motion. Newton's second law of motion tells us a great deal about velocity. It tells us that the final velocity is equal to the initial velocity plus the net force over mass times delta t, with delta t representing change in time. In this lab, we are given the guidelines that the net force is equal to 0, 0, 0 in all directions. This modifies the second law, leaving us with just the final velocity equivalent to the initial velocity. Additionally, the position formula can be derived from the fundamental equation. It is that the final position is equal to the initial position plus average velocity times delta t. This will be later used in VIDLE. In recording an object following a constant motion in a constant direction, I recorded a roll of masking tape rolling across the table. The frames used were from the center of the video to best capture the tape rolling at a constant speed in a program called Tracker. Here in Tracker, we tabulated all of our results. Here's the ball in motion. The coordinate axis implemented followed suit of the customary axes, where the positive x-axis is parallel to the surface pointing to the right, and the negative x-axis pointing in the left direction. The y-axis pointed upwards perpendicular to the surface, and the negative y pointing downwards. And lastly, the positive z is pointed out of the screen along the surface, and negative z going into the screen. The only axes that were regarded in this lab were solely the x-axis, because this is a one-dimensional motion. The data from Tracker was used to record the tape's position over time, over here, and the data was then plotted on a graph giving a positive linear slope of position versus time. If the axes were flipped and the positive x-axis was labeled as pointing to the left, the final plot of position versus time would result in a negative slope which would still remain linear, such as this. Using the data that we obtained from Tracker, we can now determine the average velocity. The formula for the average velocity is change in r over change in t. The two data points that I used were the first and second position overall. Using these positions, I divided those by the time over the course of those positions and got an average velocity of 0.21. Here, in VIDLE, we will use the velocity that was just obtained in the previous slide. Here, we take the tape's mass as 0.68 kilograms, encode the initial position vector to be 0, 0, 0 for all three, and here's the velocity that we just found out to have 0.21 in the positive x direction. Additionally, this program creates a reiterative while loop. In this loop, the net force is set equal to 0 as stated here, and the ball motion is depicted by Newton's second law hard-coded into the program. The position is constantly updated as time goes on throughout this, and as a result, the final execution of this program results in this graphical representation. As you can see, the ball, just as in the video from Tracker, moves from the left to the right. Additionally, the graph of position versus time is shown as linear and positive sloped. After plotting the predicted versus observed data for the position over time, it was shown that there was a clear discrepancy between the observed and predicted positions. The observed position was longer than the predicted position after 0.2 seconds and continued on all the way until the time of 1.31, widening the gap. This discrepancy could most likely be attributed to the calculated average change in velocity to be lower than in reality. Since the average velocity was only taken from the original change from position 1 and 2, there was a lower than actual average velocity used. Additionally, by not taking into account the net forces acting on the ball and the movement in the z direction, this could have also altered the results due to the fact the still camera and its angle could not have compensated for this shift. In conclusion, a misrepresented average velocity, in addition to making the assumption there were no other impacting forces, led to the variation in results from the observed and predicted positions. By not taking into account all forces such as air resistance and tape-to-table friction along with the movement of the roll of tape in the z direction, I observed skewed results. From my observations, it was clear that there were net forces acting upon the tape, but the exact pushes and pulls could not be determined. If a true net force had been accounted for and motion in all three directions analyzed, I'm confident the data from the Tracker would have been represented by the VIDLE representation. Thank you for your time, and I hope you've learned a tad bit about an object in a constant motion and its relation with Newton's second law of motion. Thank you.